According to Rule 4-0062A, the load is rated less than 100 amps and not marked. Therefore, the temperature termination rating at the load end is 60 degrees C. In this question, the overcurrent device is marked 75 degrees, and both ends of the conductor must be considered. The insulation must have a 75-degree temperature rating. And in question 3, the lower temperature column must be used for determining the size of the conductor. When there is a different TTR at the end of each conductor, the size of the conductor must be based on the lower temperature column. Here we have a circuit consisting of a 200 amp panel marked with a TTR of 75 degrees. This circuit is supplied using RW90 conductors and protected by a 200 amp breaker marked 60/75. The circuit runs above ground and through an area which has an ambient temperature of 40 degrees C. The 40 degrees C ambient requires the circuit conductors be derated. The wording in Rule 4-006, Subrule 1, is somewhat ambiguous, but the derating factor is based on the insulation rating of the conductors. So to summarize, the insulation rating is based on the highest TTR. The conductor size is based on the lowest TTR, and the derating factor is based on the insulation rating. Here we have provided examples from Table 2 and Table 5A. In accordance with the wording of 4-006, Subrule 1, the size of the conductor, including any relevant correction factors, must correspond with the maximum termination temperature marked on the equipment. In our example, both the circuit breaker and panel board are marked with a 75-degree TTR. The derating factor is based on the value obtained in the 90-degree column of Table 5A. The corrected ampacity is then selected from Table 2, which corresponds with the TTR rating. This is 75 degrees. Number 4-aught AWG meets the minimum size required. If electrical equipment is not marked with the temperature termination rating, the TTR must be obtained from the manufacturer's specifications, or use Rule 4-006, Subrule 2 to determine the rating. Certification standards for the equipment with lugs only, such as meter bases or splitters, do not require mandatory marking of the temperature termination rating. At this time, TTR is a voluntary marking requirement. Subrule 3 requires consultation with the high-voltage equipment manufacturer to determine the termination temperature rating when the equipment is not marked with a TTR. This is a detail that should be reviewed by the designing electrical engineer and included in the plans and specifications, as well as the one-line diagram provided to the authority having jurisdiction. Subrule 4 requires the conductor size to conform to the TTR termination rules applies only to the first 1.2 meters of conductor length. Subrule 5 requires the length of a transition conductor must be a minimum of 1.2 meters long. This requirement corresponds with the length of the test conductor used during CSA equipment testing. The conductor temperature is measured during the test. 75-degree conductors of this length have been shown to provide sufficient mass to conduct heat away from the terminations and the interior components. This leaves the option to transition to another type of conductor which has a higher temperature rating and an increased ampacity. This may result in a smaller wire size when their ampacity is based on the 90-degree column.
In this example, the first step is to determine the TTR of the equipment. As the switch is rated at 75 degrees, this is the temperature column we must use. Table 2 in the 75-degree column allows 310 amps for each 350 kcm conductor, a total of 620 amps. For the underground portion, we use Table D10A and the 90-degree column. Number 4-aught Tech allows for 319 amps for each conductor, a total of 638 amps. The minimum transition cable length is 1.2 meters. The conductors in the raceway must be 90 degrees C rated to match the rating of the underground conductors. In this example, the TTR is 75 degrees. The conductor size must be determined using the 75-degree column of Table 4. The underground portion is determined using Table D10B at the 75-degree rating. This shows a 500 kcm, 2 conductors, with 2 conductor per phase as 389 amps. We need to apply the correction factor of 0.886. This leaves us with a 345 amp per phase for a total of 690 amps. No transition conductors are required as both ampacities above and below ground meet the load requirements. In this example, the equipment TTR rating is 75 degrees. First, we need to select the ampacity of the underground conductor. Using table D11B at 90 degrees, number 4/0 is allowed to carry 210 amps. Paralleled, this equals 420 amps. The maximum underground transition length is 10% of the run, or 3 meters, whichever is less. The minimum transition cable from the junction box to the switch must be a minimum of 1.2 meters. The above ground portion is sized using table 4 and the 75-degree column. This paralleled is good for 410 amps. This meets the load requirements. These SPT1 and SPT2 flexible cords are new to table 12. Changes to table 12 include odd-size conductor listings and their ampacities, new flexible cord types SPT1W and SPT2W, and new notes for SPT1 and SPT1W.
That's all for Section 4. Thanks for watching.